Hi. Hey guys at home, thanks for joining us. We're kind of going to hit the road running today. So we are finishing up stoichiometry notes today. We're going to be looking at limiting reagents and percent yield. Limiting reagents is one of those honors topics that we deal with. Sorry, I still got a couple people popping in from the lobby. Here we go. So limiting reagents is one of those honors topics that we deal with. It's not really anything truly new calculation-wise. It's going to be using the same calculations we've used before, but looking at problems slightly differently. So we're going to get through the notes today. We'll do at least one example of each. If you guys feel like we need a second one, we'll do a second example. And then we're going to move over and do the lab setup portion. And then you'll kind of have the work time afterwards to work on your homework that's due tomorrow. So remember, it's not due on Tuesday this week, it's due on Wednesday. So there's only a couple problems left if you've kind of been keeping up. But that way you have a little bit extra time. So looking ahead with limiting reagents. So in a chemical reaction as a whole, if we have an insufficient quantity of any of the reactants, so if we have less of one of the reactants than the other, it can actually limit the amount of product that forms. So if we run out of one of our reactants, the reaction is going to stop running. So this is our limiting reactant or limiting reagent. It's the reagent that determines the amount of product that can be formed from a reaction. So this will run out and be used completely up. And once we run out of that reactant, the reaction ends. It can't make any more product than what it already has, because it has to have both reactants to make products. Whatever does not run out, the other reactant is our excess reagent. So this is not completely used up in the reaction. So some of it reacts, and then you're going to have leftovers. And whenever we're finding the limiting reagent, we have to convert both reactants into the same product so that they can be compared. So up to this point with stoichiometry, we've been given only one reactant to start with. We've been given one amount. With limiting reagents, it will give us both reactant amounts. So we have to take both of them and change them into products. And we're looking for whichever one runs out. So whichever one produces the smallest amount. And that's how much can be made, because that's going to be kind of our limiting reagent. Once that one runs out, the reaction's done. So the stoichiometry that we've been doing is the exact same, but since it gives us two starting amounts, we're going to have to do two problems. And we're going to be looking for the least amount, because that's how much is produced, and then the reaction stops. All right, I think everybody's with me. All right. So let's look at this problem. And if you're following along on the PowerPoint, I did add this secondary question. So I kind of added a question after this one. But wants to know, what's the maximum number of grams of copper 1 sulfide that can be formed when 80 grams of copper reacts with 25 grams of sulfur? And how much excess remains? And I gave you the reaction of 2 copper plus sulfur produces the copper 1 sulfide. And I'm just going to draw our little, you're right. Thanks. Sorry. So I'm going to draw our little double roadmap. So moles can be converted into particles, grams, or liters. And remember, we can convert that into moles of another substance, which can be converted into particles, grams, or liters. So this is 2 questions. I added that second question on there of how much is excess, because there is one like that on your homework, and I want to show you how to approach kind of a secondary question after you found the limiting reagent. So I got a couple people writing the problem, so I'm going to pause and let them kind of get with me. So kind of looking at what we're going to be doing. So it wants to know the maximum number of grams of the copper 1 sulfide. So we're looking for grams as our final answer. And it gives us grams of copper and grams of sulfur. So we're going to be changing from grams into grams. So that's the path we're going to have to take. Since it gave us both reactants, the copper and the sulfur, we're going to do a conversion with both of these. So we're going to do them separately. So we have the 80 grams of copper and the 25 grams of sulfur. So look at these kind of one at a time. So looking at the grams of copper first, we're going to be changing from grams of copper into grams of that copper 1 sulfide. So our first step is to go from grams to moles, always. So where does grams need to go in our next step? Yep, down at the bottom. So we can change into grams of copper, from grams of copper into moles of copper. Just remember, grams per mole is always out of 1 mole. And grams is the molar mass. So copper's mass on the periodic table is 63.55. So that's going to allow copper to cancel with grams and leave us with moles of copper. So that got us to the first M. Then we have to change from moles of copper into moles of the copper 1 sulfide. So moles of copper needs to go down to the bottom. And we can change into moles of the copper 1 sulfide. So remember the mole to mole step, you're going to use those coefficients from your balanced reaction. So that will cancel out moles. And now we have moles of copper 1 sulfide, but we're looking for grams of copper 1 sulfide. So we can add one more step on here. So moles we don't need anymore, so it has to go down to the bottom. And we can change into grams on top. So grams, we need molar mass. So we said copper had a mass of 63.55, but there are 2 of them, so make sure to double that mass. And add to it sulfur is 32.07. So that's a mass of 159.17. So that's going to allow moles of the copper 1 sulfide to cancel, leaving us with grams. So that's all we need to do for that problem. So calculate, remember, anything on top we multiply by, Anything on the bottom we divide by. So 80 divided by the 63.55 divided by 2 times the 159.17. So this will make 100.2 grams of copper. Or, yeah, I probably shouldn't circle it yet because we still have to calculate the other one. So we have enough copper to make about 100 grams of the copper 1 sulfide. So that's a pretty decent amount, but we don't know if we have enough sulfur to make more of that copper 1 sulfide or less of the copper 1 sulfide. So we also have to calculate this with the sulfur. So we're going to go through the same process. We don't need grams of sulfur anymore, so that has to go down to the bottom to change into moles of sulfur. So grams per mole is out of 1 mole, and the molar mass of sulfur is that 32.07. So that cancels out grams. Now we have moles of sulfur. So to get to grams of the copper 1 sulfide, we first have to get to moles of the copper 1 sulfide. So where should moles of sulfur go in our next step? Yep, down at the bottom. So change into moles of the copper 1 sulfide. So looking at our coefficients, there's 1 sulfur, 1 copper 1 sulfide. So that cancels out moles of sulfur. And then we have moles of copper 1 sulfide, but we need grams. The nice thing is limiting reagents, this last step is always going to be identical since we're changing into the same substance, because moles will go down the bottom and mass will go on top. So we can just copy that step down, because 1 mole is going to be that 159.17 grams. So that will leave us with grams of the copper 1 sulfide. So then we can calculate how much can be produced based off of our sulfur. So 25 divided by 32.07 times 159.17 is 124 grams of copper 1 sulfide. So the sulfur is going to be able to make more product, but we said the maximum number of product is whatever the lowest number is, because once that's produced, we're out of one of our reactants and the reaction stops. So our answer is that 100.2 grams of copper 1 sulfide is what can be reduced, because that's all the copper we have. Once we hit that 100.2, we're out of copper, so the rest of the sulfur can't react. It's going to be leftovers. So that addresses that first question of what's the maximum number of grams of copper 1 sulfide that can be formed. Here's where that secondary question comes in, the how much excess remains. I added this because, like I said, I wanted you to see what happens when you have a secondary question after you found the limiting reagent. So we want to know how much excess remains. So we want to figure out our excess is the sulfur. So we want to figure out how much sulfur is left over that did not react. One thing that you'll come across anytime you have a secondary question, whether it's how much excess is left over or how much of the other product is formed, something like that, you always start with your limiting reagent. So we're going to start with that limiting reagent. that 80 grams of copper. And we want to change it into that excess reagent. So we want to change it into grams of sulfur. That way we can subtract from that original amount to see what is left over. So we're still doing the exact same steps. We're going from grams all the way to grams, but we're changing from the limiting reagent into our excess reagent. So we can actually use pretty much all the numbers are already up here in these upper problems. So we need to first change from grams to moles. So to get rid of grams of copper, that goes down on the bottom to change into moles. And I'm going to scroll up just a hair so my guys in the back can see. Ooh, that was a little too much, but that way my guys in the back can see a little bit better. So 1 mole is the 63.55. So we had that mass in our first reaction. If I can write. Yeah. Then we need to change from moles of copper into moles of sulfur. So that mole ratio step. So since we have copper, it's got to go down to the bottom and change into moles of sulfur. So with our reaction, we have 2 coppers for every 1 sulfur. And then we said we're changing into grams of sulfur. So moles of sulfur needs to go down on the bottom. And that molar mass was that 32.07. So that allows moles of sulfur to cancel. So this is going to tell us how much sulfur reacted with the 80 grams of copper. So we'll do the 80 divided by 63.55 divided by 2 times 32.07. So this is 20.2 grams of sulfur that react. So to figure out how much excess we have left over, we want to take our original amount, that 25 grams, and subtract how much reacts, that 20.2 grams. So there should be about 4.8 grams excess. So 4.8 grams left over that can still react if you have more copper to react with. So like I said, this is an example of a problem that might come up on your homework. Like I said, if it was something like a double replacement reaction, it might ask you how much of the other product is formed. So any secondary question, you're always going to start with the limiting reagent. So I know that was a lot because that was 2 questions in one. Do you guys want me to do another limiting reagent problem? I'm going to take silence as a y'all are good. Okay. There are other problems if you need to go and try these. Like I said, it's the exact same stoichiometry that we've been doing, but you're solving for both reactants and you're looking for the smallest amount of product. Okay. So let's flip over to percent yield. So all right. So percent yield, this is something that we use a lot, especially in a lab setting. So we're dealing with actual yield and theoretical yield. So theoretical yield is going to be our maximum amount of product that could be formed from the given amount of reactant. This is going to be our calculated value. So this is our answer from a stoichiometry setup. So whenever you are taking the amount of reactants and calculating how much product should be formed, that is your theoretical yield. This also tends to be in grams, is what we want to change into. You're also going to deal with your actual yield. So this is what you get whenever you perform a lab, you make the product throughout the lab process, put it on the scale to measure how much you made. So this is the actual amount formed or produced in a lab experiment. And a lot of times this tends to be less than the theoretical. So a lot of times we end up making less than we think we should be able to make. So this is going to be a given value. It's going to tell you like this much is produced or is found or is made in labs, something like that. And percent yield is going to be our ratio of our actual yield, what we made in lab, compared to our theoretical yield that we mathematically should be able to make, and then times 100 to make a percent. So here's our formula. This percent yield is equal to the actual over the theoretical times 100. And this is usually going to end up being less than 100%, because a lot of the times not all of it reacts. Maybe we didn't leave it in long enough, things like that. There are instances where it can be over 100, but that tends to mean that there's extra stuff in there. Like maybe it has water and you didn't dry out all the water or something like that. But majority of the time it will be less than 100. And sometimes you'll see this as two separate questions. Sometimes it'll ask you to find the theoretical yield, and then a second question will ask you to find percent yield. Ones that tend to be a little bit more challenging are whenever it's all within one question. So we're going to do an example of one of those, because those tend to be the harder ones, because you're going to be given two values and you have to figure out which one is your actual yield and which one you need to use to start your calculations for theoretical yield. All right, so if you're following on the notes, I'm going to skip to the last slide that has an example that has both of them in the same question. I think everybody's with me. All right, so let's look at this question. And I'll write the reaction for you guys because normally the reactions will be given. Bless you. So we want to know, what is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with an excess of copper 2 sulfate? So I'm going to go ahead and write our reaction out. So here's our reaction of, we have 2 aluminum plus 3 copper 2 sulfate produces 3 copper and the aluminum sulfate. So here it gave us both numbers and it's asking for percent yield. So we need to figure out what is our actual yield, and then the other number is what we're going to do stoichiometry with, because in order to be able to compare two numbers, they need to be in the same unit. So like I said, for actual yield, you're going to be looking for some keywords of how much was obtained or was found in lab or was created or made or produced. So here it tells us that the 4.65 grams of copper is produced. That is going to be our actual value. So we're kind of going to leave that alone until we're needing to calculate that percent yield. Our other value, the grams of aluminum, is what we're going to change into our theoretical value. So this is our reactant of what we're starting with. And we want to look at how much product should we be able to make based off of the overall reaction and stoichiometry. Because in order to plug into percent yield, they have to be in the same unit. So we need to change grams of aluminum into grams of copper so that we can compare it to that actual yield. So we're going to start with grams of aluminum. So the 1.87 grams of aluminum. And feel free to draw that little mole roadmap if it helps you. So our first step is always to change into moles. So we don't need grams of aluminum anymore. So where does it go in our next step? Yep, down at the bottom. And we can change into moles of aluminum. So remember, grams per mole is always 1 mole. And grams of aluminum is 26.98 is its mass on the periodic table. So that's going to cancel out grams of aluminum. And now we have moles of aluminum. So here's where we can change from moles of one substance into moles of the new substance. So since we're looking for grams of copper, we need to first get into moles of copper. So moles of aluminum has to go down to the bottom. Moles of copper can go on top. So remember, mole to mole, use your coefficients from your balanced reactions. There's 2 aluminum for every 3 copper. So that's going to cancel out moles of aluminum, leaving us with moles of copper. And then we need to change to grams so that it can match that actual yield. So theoretical yield generally always change into grams. So moles of copper goes down the bottom. Grams goes on top. So grams is always out of 1 mole. And copper's molar mass is that 63.55. So that cancels out moles, leaving us with grams. So this is going to give us our theoretical yield. So we're going to do the 1.87 divided by 26.98 times 3 divided by 2 times the 63.55. So this is going to be 6.61 grams of copper. So like I said, that's our calculated value. That is our theoretical yield. So whenever we're finding percent yield, which is what it's asking, so we're still not done, we said it's the actual, so the 4.65 divided by the theoretical yield. Our calculated value always goes on the bottom. So 6.61 times 100 to make it a percent. And that's going to be 70.3% yield. So that means that in lab, we only made 70% of what we should have. So this might be maybe all of our aluminum wasn't in the solution, so not all of it reacted. Maybe it wasn't pure aluminum. Maybe we have excess water in there. Maybe we didn't let it sit and run long enough, so not all of it reacted. There's kind of a whole variety of things that could have caused that difference. Plus, you know, with a piece of aluminum, maybe there's aluminum in the center and only the aluminum on the outside reacted. There's tons of things that could have occurred to cause that percent yield. And sometimes you might get really, really small numbers for percent yield. That is possible. It just depends on what values you're given. I have a hand up from Kendall.
So because we went from grams of aluminum to the grams of copper, does that mean that that was the excess that it's asking about?
This is just like how much is produced. So it told us that we had an excess of copper 2 sulfate. So aluminum in this case would be like our limiting reagent. So this is how much product can be made based off of how much of the limiting reagent we have.
Okay, so we don't have to find the excess in this one?
No, only if it like specifically asks for it. So that is all of percent yield. So like I said, not a ton of new stuff today. So limiting reagent, it's the same stoichiometry math, but you're doing it for both reactants and you're trying to figure out which one makes the least amount. For percent yield, you do the stoichiometry to figure out your theoretical yield and then plug it into that percent yield equation. Does anybody want me to do another percent yield example? Okay. So, Hannah, I'm going to stop recording and then we can keep going.